So today we are going to do lab number 7, microcontroller based system design, and at this lab we are going to learn how to control the motor by using microcontroller. Our main focus on first 3 labs in the final term, lab 6, 7 and 8, we learn how to design a robot. Robot is an autonomous device. Okay, that means robot can take its own decision by sensing the environment and accordingly take action. In the lab number 6, we have learned what is microcontroller, how to program the microcontroller, what is the application of the microcontroller. In this lab, we are going to focus on the motor control. Motor control is one of the essential parts if you want to design a robot. Robot has 2 main parts. One is the sensing part. That means through the sensors, robot will sense the environment and it will analyze the data of the surrounding, and accordingly it will take decision. And based on the decision, it will take action through the motor control. So today we learn how to control the motor. So this is the objective in this section: getting familiar with the microcontroller based system, introduction to Arduino Uno project board, introduction to motor shield, how to code a simple program to control the motor rotation, and how to simulate the code in Proteus and observe the results. In this lab, we are going to take the advantage of cutting edge technology of Proteus. It is called drag, drop, play method. Okay. In this cutting edge technology, drag, drop and play method, you don't need to be tech savvy. That means you don't need to be expert in programming. With basic understanding of the system design, with your concept, you can directly go to the production or application design. You should have your idea, you should have your concept, and implement the concept through flowchart. The system will take care of the coding. So you design the system, you draw the system in flowchart, and system will do the rest of the things. Okay. So that's the drag, drop, play method that we are going to employ today. But before we go to the drag, drop and play method, I am going to explain some theory behind this lab. First, what is a microcontroller? A microcontroller is a small computer on a single integrated circuit containing a processor core, memory and programmable input-output peripherals. Now, what is Arduino? Arduino is a tool for making computers that can sense and control more of the physical world than your desktop computer. It is an open source physical computing platform based on a simple microcontroller board and a development environment for writing software for the board. Arduino can be used to develop interactive objects, taking inputs from a variety of switches or sensors and controlling a variety of lights, motors and other physical output. Arduino projects can be standalone, or they can be communicate with software running on your computer. Okay. The boards can be assembled by hand or purchased pre-assembled. The open source ID can be downloaded for free from the net. Okay, if you give a search on the net Arduino ID, you can directly go to the website and download the software. Let me show you how to go to the website and download the software. Okay, type Arduino ID here, DUINO, Arduino ID. Arduino ID download. But I think before I go to the download, okay, let me visit the home page of the Arduino because it has some exciting information, some new addition. Okay, Okay, you can download the Arduino software from here. You can either write the code online, Arduino web editor, or you can download the ID for your installation in your own desktop or laptop computer from here. If you have a Windows system, you can download the Windows installer. If you have the Mac system, you can download the Mac installer. Linux system also available. Okay, so it is available for almost all the computer platform. Okay, now go to the hardware side. Hardware. Okay, professional. Let me check the professional option. Main products, entry level product. Arduino has a different flavor or variety of board. Okay, look at over here. This is the entry level Arduino board. Among this entry level board, this Arduino Uno is the most popular. It is widely used because it is very low cost, and for the starter, this is the first choice, Arduino Uno. Okay, today in the lab we are going to use this board, Arduino Uno. If you click the board, Arduino Uno, it will show you the description of the board. Okay, price is gradually day by day coming down. Okay, and in our market, I think you can buy this board around 400 taka, very cheap. Okay, the Arduino Uno is the best board to get started with electronics and coding. If this is your first experience tinkering with the platform, the Uno is the most robust board you can start playing with. The Uno is the most used and documented board of the whole Arduino family. That means if you want to design a program, or if you want to design a system, and if you need help in coding, just give a search on Google. And I believe, or what I have found, for almost any type of system problem or coding problem, you will certainly get a very good help from the net. Okay, for this board. So this is the first choice. Okay, so Arduino Uno is a microcontroller board based on Atmega 328. Okay, it has 14 digital input-output pins, of which 6 can be used as PWM output. 6 analog inputs. That means on this 6 analog input pin, you can connect sensors to sense the environment, and a 16 megahertz ceramic resonator, a USB connection, a power jack, an ICSP header, and a reset button. It contains everything needed to support the microcontroller. Simply connect it to a computer with a USB cable, or power it with AC to DC adapter or battery to get started. You can tinker with your Uno without worrying too much about doing something wrong. Worst case scenario, you can replace the chip for a few dollars and start over again. Okay, if you look at the diagram, this chip, if you do something wrong in the worst case, just replace it. Very low cost, this is around 100 taka in our market. Okay, this low cost chip. Uno means one in Italian and was chosen to mark the release of the Arduino software ID 1.0. The Uno board and the version 1.0 of Arduino software ID are the reference versions of the Arduino, now evolved to newer release. The Uno board is the first in a series of USB Arduino board and the reference model for the Arduino platform. For an extensive list of current and past and outdated boards, see the Arduino index board. Okay, so this website has a complete listing of all the different boards, and we are especially interested of the Arduino Uno board today. This is the technical specification. If you click the tab, okay, operating voltage is 5 volt, input voltage recommended 7 to 12 volt, you can go. Okay, you can give 7 to 12 volt, that means you can tolerate. Limit is 6 to 20 volt. You recommend 7 to 12 volt, but limit is 6 to 20 volt, you can go. It has digital I/O pin, 14 digital I/O pin, of which 6 provide PWM output. That means you can simulate analog output on the PWM pin. PWM digital I/O pin are 6, okay. Analog input pin 6. DC current per I/O pin is 20 milliampere. DC current for 3.3 volt pin is 50 milliampere. This is important. How much current your board can sustain? Because why it is important? Because today, to control the motor, we need to connect the motor to the microcontroller, right? Now, every motor draw a huge amount of current. Okay, several ampere, less than 1 ampere to several ampere current it can draw depending on the size and capacity of the motor. Now, if you connect those ampere hungry motor to the microcontroller, what will happen? Huge current it will draw and it will burn your microcontroller board. So you cannot connect. Look at the rating. You see, DC current per I/O pin is 20 milliampere, and your motor is drawing around less than 1 or several ampere or many ampere current it can draw depending on the size. Okay, so you cannot connect the motor directly to the microcontroller I/O pin. So what is the solution? We need some way to give the power source for the motor from external source. Okay, that means motor will get its power from external source rather than from microcontroller. Then what microcontroller will do? Microcontroller will send the controlling signal to control the motor rotation. Start the motor, stop the motor, right rotation, left rotation. Okay, it will send the controlling signal to the I/O pin, and the main power the motor will get from external source. So to achieve this capability, we use a device called motor driver IC. Okay, motor driver IC. So now I will take you to a video on YouTube channel that will nicely explain how and what type of motor driver IC are available and how it helps to connect the motor. So let me play a small video.
Hey, what's up guys, welcome back. In this video, I'll explain you what is a motor driver and how to choose a good motor driver. So, a motor driver is a breakout board which consists of a motor driver IC. I am using a motor driver breakout board which consists of an L293D IC. A motor driver circuit board is used for running the motors. It is like a current amplifier, and the main purpose of the motor driver is to take a low current signal and convert it to high current signal so that it can run the motors. The reason why we require a motor driver is because components like motors cannot be connected directly to the Arduino as they do not get sufficient power from the Arduino. So we basically connect the motors to the motor driver first and then supply power to the motors using a battery through the motor driver. Now, since I've taken many workshops on embedded systems and robotics, here are 3 of the motor drivers that I have used. All the 3 breakout board uses an L293D IC, which is a motor driver IC. The L293D IC is a 16-pin IC, out of which 4 pins are input pins and 4 pins are output pins. Pin number 2, 7, 10 and 15 are input pins, and pin number 3, 6, 11 and 14 are output pins. You can also see it consists of 4 ground pins, that is pin number 4, 5, 12 and 13. Pin number 1 and 9 from this IC is called as enable pin, which requires 5 volts of power for operation. Pin number 16, which we can call as VCC pin, also requires 5 volts of supply. And at pin number 8, we need to give external power between 5 to 12 volts. That is, we need to provide external power using a battery or an adapter. Now, since we are using this motor driver circuit to control a robot, we will require a battery instead of an adapter. Now, if you are using just a motor driver IC, then you have to do all the connections by yourself on the breadboard first and then connect the entire circuit to the Arduino. So instead of doing the entire connections by yourself on a breadboard, it is better that you purchase a motor driver breakout board. As the motor driver breakout board consists of sockets in which we have to connect the input wires from the Arduino, the output wires from the motors, and it also consists of a power supply socket where we can directly give power from the battery. Now guys, as you can see in front of the screen, there are 3 motor driver breakout boards. And in all the 3 motor driver breakouts, you can see that there are pins or sockets to connect the input pins from the Arduino, and there are output sockets to connect the DC motors. There is also a power socket where you can connect the external battery. So out of the 3 breakout boards which are present, I'll first explain you the breakout board which is there on the left hand side. Now if you look at the first motor driver, then it consists of 3 green sockets, 2 at the bottom and 1 at the top. It also consists of 4 data pins on the top left side. The input pins of the L293D motor driver IC, that is pin number 2, 7, 10 and 15 can be accessed from the top left side over here at A1, A2, B1 and B2. To these pins, we will provide inputs from the Arduino's data pins. The 2 green sockets at the bottom are for connection to the DC motors. So, the output pins of the motor driver IC, that is pin number 3, 6, 11 and 14 can be accessed from these green sockets. Each socket consists of 2 holes in which we have to insert the DC motor wires. And you can also see the green socket which is present on the right hand side is used to supply external power to the motor driver using a battery. Now, if you look closely, then there are 2 more pins for VCC and ground. So, at the VCC pin, we had to provide a supply of 5 volts from the Arduino. That is, I had to supply power from the 5 volt pin of the Arduino to this VCC pin. And I also had to connect 1 ground pin to the ground pin of the motor driver. So guys, the disadvantage that I found of using this motor driver is that I also had to give 5 volts of supply from my Arduino to the VCC pin of this motor driver. Now, if you look at the second motor driver over here, then it consists of 5 green sockets. The input pins of the L293D IC are connected to the top green sockets which are labeled as M1in and M2in. So, at M1in and M2in, I had to connect the inputs from the Arduino. The output pins of the motor driver are connected to the bottom green sockets over here, which are labeled as M1 out and M2 out. So, to these sockets, I have to connect the DC motors. You can also see that there is 1 more green socket on the right side, and to this green socket, I had to give external power using a battery. The advantage that I found of using this motor driver is that I did not have to give 5 volts of supply separately to this motor driver breakout from my Arduino, because the circuitry of this breakout board is made in such a way that the VCC and the enable pins get the required 5 volts from the external battery itself. So in short, the motor driver basically converts the incoming supply from the battery and gives 5 volts of power to the pins that requires 5 volts. And if you look at the last motor driver, then this motor driver is more advanced than the other 2 motor drivers. It consists of D1, D2, D3 and D4 pins which are connected to the input pins of the L293D IC. And as you guys would have guessed, these pins will be connected to the Arduino's data pins. The DC motors will be connected to the green sockets which are labeled as M1, M2, M3 and M4. And I had to connect a battery to the DC jack connector for providing power. The breakout board also consists of an on-off switch using which I can switch on and switch off this board. Now, like the previous motor driver, I also did not have to give separate 5 volts of supply to this breakout board as well. So guys, when you purchase a motor driver breakout board, please check its specifications and also verify whether you need to provide 5 volts of supply from your Arduino or not. That's it from this video. I hope from this video you would have understood what is a motor driver and how you can choose a good motor driver. Hey, what's up guys? In the previous video, we talked about the motor driver breakout board and the L293D motor driver IC. Now, in this video, I'll explain you the working of L293D motor driver IC. The L293D IC can control two motors at a time. It consists of a dual edge bridge motor driver circuit. That is, the motor driver IC consists of two circuits like these, one for each motor. Now, before I start explaining you the working of motor driver, let me explain you a very simple concept. So, if suppose you want to determine the number of input or output combination according to the devices you have, then there is a very simple formula for that. For example, in the first section, we have written a program to blink the LED. Now, since we had only one LED, there are two outputs possible. First, your LED will be high. Second, your LED will be low. So, from the LED example, let's look at the formula. Now, if you have one digital device, then your N is equal to 1. And the formula to determine the number of input and output combination is 2 raised to n. So, for n equal to 1, there are two outputs possible, that is high and low. Now, since we have to control a robot and our robot consists of two motors, then n is equal to 2, and so the combination logic is equal to 2 raised to n, that is 2 raised to 2 equal to 4. So, for two motors, there are 4 input combinations possible. And these combinations are 0, 0, 0, 1, 1, 0 and 1, 1. That is low, 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 high, high, low and high, high. And when we apply these inputs to the motor driver from the Arduino, the motor driver will thus control the motors. So now, as you can see, this is an edge bridge circuit, and this edge bridge circuit can control one motor. On the right hand side, there is a table indicating the input and output conditions. The input conditions of high and low are given from the Arduino to the input pins of the motor driver, and then from the output pins of the motor driver, the DC motors will be controlled. The edge bridge circuit basically consists of 4 switches, S1, S2, S1 bar and S2 bar, and we need to give the inputs from the Arduino to these switches. On the top there is a VCC pin, and at the bottom there is a ground pin. In the middle there is a motor, and for this motor to move, the current should pass from VCC to ground. So first, if we give an input of 0, 0, that is S1 is 0 and S2 is 0, then the S1 and S2 switch will be open. Similarly, the S1 bar and S2 bar switches will be closed. So, since the S1 and S2 switch is open, the current will not flow from the VCC to ground, and at this condition, that is 0, 0 or low, low, the motors will stop. Next, if we give an input of 0, 1, that is S1 is 0 and S2 is 1, then S1 will be open, S2 will be closed. Similarly, S1 bar will be closed and S2 bar will be open. So, when we give a condition of 0, 1 or low, high, then the current will flow from VCC to S2, then to the motors. From the motors, it will go to the S1 bar, and from the S1 bar, it will go to the ground. And in this case, our motors will move, but it will move in the backward direction. So guys, at low, high, the DC motor will move backward. Next, if we give a condition of 1, 0, that is S1 is 1 and S2 is 0. So in this case, the S1 switch will be closed, S2 switch will be open. Similarly, S1 bar will be open and S2 bar will be closed. So guys, in this case, the current will flow from VCC to S1. From S1, it will go to the motors. From the motors, it will go to S2 bar, and from S2 bar, it will go to the ground. So guys, when you give a condition of high-low, the DC motor will move, and it will move in the forward direction. And last, at the condition of 1, 1, that is, if S1 is 1 and S2 is 1, then in this case, the S1 and S2 switch will be closed, and the S1 bar and S2 bar switches will be open. So guys, as you can see, this condition basically represents a short circuit condition. So at this condition, that is 1, 1 or high, high, the motors will not move because the current will not be able to flow from VCC to ground. So guys, if we run through all the conditions again, then at low, low, the motors will stop. At low, high, the motors will move, but in the backward direction. At high, low, the motors will move in the forward direction. And at high, high, the motors will stop. Now guys, after understanding the conditions, let's look at a very simple example. If you connect pin number 3 and 4 from the Arduino to the D1 and D2 pins of the motor driver. Similarly, if you connect pin number 5 and 6 from the Arduino to D3 and D4 pins of the motor driver. Next, if you connect the M1 and M2 socket of the motor driver to the left motor, and if you connect the M3 and M4 socket of the motor driver, then when you write any command on pin number 3 and 4, the left motor will be controlled, and when you write a command on pin number 5 and 6, the right motor will be controlled. Now, as I explained you earlier, if you want to move the motor forward, then the condition for that is high-low. So, if I want to move the left motor forward, then I will write high on pin number 3 and low on pin number 4. Similarly, if suppose I want to move the right motor backward, then I will write low on pin number 5 and high on pin number 6. So guys, I hope from this video you would have understood what is an edge bridge and how we can use the edge bridge to control our DC motors.
So till now we have given you the introduction, okay, how to connect the motor to the Arduino microcontroller board. Now is the time to design our system. On your left sheet, the basic procedure has been explained. You see, if you look at the diagram on your left sheet, the connection to the motor driver ICL 293D chip has been shown over here. Motor 1, motor 2, the connection to the Arduino microcontroller board, and the connection to the LCD display. And then 3 buttons to control the motor: stop button, reverse button, and forward button. And the code behind it, okay. The basic procedure has been shown on the left sheet. But today we are going to take the advantage of cutting edge technology, drag drop play method of Proteus. So let me start Proteus and show or guide you how to design your system. I have prepared a small documentation for your reference so that you can do the lab by yourself once I go with the demonstration. Okay, the entire circuit connection and Proteus has been shown over here. This is drag drop play method. You just drag different components and you don't need to worry about the connection. Okay, the system will take care of the connection automatically. Sometimes if you see the overlapping connection, you just can change it manually. Otherwise, in most of the time you see the system does the job automatically for you. Then this is the flowchart method that we are going to do. Okay, we are going to do this flowchart. This is the setup part of the program. Okay, then this is the loop part. We call 3 functions in the loop part: forward, reverse, and stop. Then we define the function of forward. We check the button. If the button is pressed, then we run the motor in forward direction, and also we can define the speed of the motor rotation. Then we can display a message that on the display that the motor is moving forward. Okay, so we define the message and we call a function called display message that we define over here. This is the display message function, so that the OLED display you can display the message. Okay, first we clear the display, then we can set the text color, different color you can use, then text size you can define, then we can set the cursor at what location I will display the message, then we will print the message, and then by using the display function it will be displayed. Okay, so this is the display function to display the message. So this is the reverse function. Same way we have used the forward function, same way we do the reverse function. So we test the button. When the button is pressed, then we run the motor in reverse direction and display the message. Okay, and wait 100 milliseconds. Okay, this is the stop function. We check the button, stop button. If the button is pressed, then we stop the motor. Okay, then display the message, motor has been stopped. Okay, so let me do it. Okay, let me show you a step-by-step guideline through Proteus. Let me run Proteus. Okay, right click the Proteus icon and run it as administrator. run as administrator. Okay, so we see an interface like this. When you run the Proteus, you will click the button New Flowchart. So give a name to your project. CSN Lab 7 motor control. Okay, and you can also specify the location where it will be set. Let me browse the location. Let me save in your folder. Let me it's a D drive, fall 2020, and this is the file CSL lab number 7. Okay, so let's save it over here. Select folder. Now create flowchart project. From the family, you can choose the Arduino Uno board or Raspberry Pi. I am choosing Arduino family. Then controller can be Arduino Leonardo, Mega, Arduino Nano, Arduino Uno, Arduino Neon. There are different types of Arduino board. Okay, we will choose Arduino Uno board. Now compiler, visual designer for Arduino here. Okay, that's come with the software. So click the next button. This is the design window and the firmware. So both are clicked. So finish. Click the finish button. So it will create the design window and the flowchart window. So it is working. Depending on your computer speed, it does the work. It is a little bit more time in my computer because there are many programs are running. Microsoft Teams is running. Adobe Acrobat is running. Okay. Internet Explorer is running. Many software is running. So it is taking a little more time, but I have found it. Okay. So this is the visual designer, or you can write the flowchart for your program. Okay, this is the flowchart that I have shown you that we are going to implement today. Okay, we are writing this flowchart over there, and this is the design window. You see, it has already placed the Arduino Uno microcontroller breakout board. Let me enlarge it a little bit so that you can visualize properly. Okay, so this is the analog pin, AD0 to AD5. This is the digital I/O pin. Okay, this is the reset pin and the built-in LED of the Arduino Uno, pin number 13. Okay, this is the pin number 13. Built-in LED on the board, that's on pin number 13. Okay, and this is the reset pin. So the first thing we are going to do today, we are going to place the motor driver board. Okay, to do it, we'll click the file button, file, import, project clip. Okay, so click the folder Arduino and find out the motor driver board. Scroll down And lots of breakout board sensors available for your ready-made, ready to use. Okay, just pick up the motor. You see, Arduino motor shield. Okay, different types of motherboard are available. We are going to pick up this one, Arduino motor shield with DC motor. I think we need to place it. I think let me reduce the size so that it is easier. Drag object.
So এখানে স্যার যে মোটরটা আমরা ইউজ করতাম স্যার সেখানে দুইটা মোটর কন্ট্রোল করতে পারবো আমরা না?
Yes, but two DC motor. Again,
যদি করতে চাই তখন স্যার
then you can use two devices like this. Okay, 4 motor. I think there are several variations. Let me show you some variation. Let me pick up this board. You have some picture. Okay, let me do it different way. Go to the visual designer, right click the peripheral, add peripheral. So you can see the picture, okay, of the motor driver board so that you can choose. Let's say choose motor control. Look at over here, motor shield version 2 with servos, DC and super motor. You can connect how many motor? Over here 1, 2, 3, 4, 5 motor. You see, you can connect servo motor, DC motor, stepper motor over here. With this board you can connect how many motor? 1, 2, 3, 4 motor. So there are variation of the board. Okay, with this board you can connect 1, 2, 3, 4, 5, 6 motor. With this board you can connect 2 motor. Okay, so there are variation, you see. With this board you can connect only a single motor, I think. With this board you can connect what is Arduino Jumo robot. This is for the Jumo robot motor controller board. Okay, Arduino Turtle motor controller board. So there are many variation of the motor controller board in the market. Okay, these are the only variation. Okay, if you browse the net, many companies come with the motor driver board. Okay, they have different capability, different functionality. Okay, so for your requirement, just browse the net and find your right board. For this lab, we are going to pick up the simple one with 2 DC motor. So let me add it. Peripheral not added. Check the file name of the project clip and the descriptor match. Okay, let what happened, because we have already one board over there, so that is making conflict. So let me do it like this. Let me close it. Already is over there. Okay, already board is over there. Okay, so we have the board and 2 motor. Okay, this is the motor DC. Okay, this is the board. Okay, so this is okay board available. Separately you can also connect the motor. Okay, let me just skip it. So this is a motor device. This is the DC motor. Okay, click the selection mode, otherwise it will keep on drag and dropping the component. Okay, so if you see that it is your icon is holding the component, click the selection mode, then it will not show the component. Otherwise, if you click the component mode, then it is drag and drop. You see, you can drag and drop the component. So let me select the selection mode. We can select the new item. So next we are going to add 3 buttons. Start button, okay, forward button, reverse button, and stop button. So go to the file, import project clip, Arduino. Let's pick up the button breakout. This is Arduino button breakout board. Click place over here. 3 buttons we are going to pick up. Button 1, another button, file, import project clip, Arduino button breakout board. One is for forward button, reverse button, other is the stop button. Button record. Okay. Next, we are going to add a display. Go to the Visual Designer, right click the peripheral, add peripheral. Now add the display. You see, this is the group 128x64 OLED display module. Let me pick up this one. There are different type of display available for use over here. Okay, let me pick up the first one. Add. To place the projector on the, okay, you see that there is sufficient space. Okay, let me make some space because it is not finding a space for it. Okay, let me move it. Okay, I think let me move this button. Okay, let me then select all the button, move it a little bit down, and let me try now to place it. Okay, hopefully it will do, otherwise it will take a rearrange. Okay, again go to Visual Designer, right click, add peripheral, add. This time it is successful. Look at over here, it has added the OLED display. Now, first thing, before going to flowchart, we need to check whether there is any conflict on the pin connection. Let me enlarge it. You see, this is pin number 2. All buttons are pin number 2. So we need to change it. Okay, different pin we need to connect. Let's say pin number 0, 1, and 2. Pin number 0 will connect the stop button. So double click the pin of the stop button and uncheck the box locked, and you can select the pin. Let's say pin number 0. Then lock it. Okay. So stop button is connected to pin number 0 of the digital pin. Then let's say this is the reverse button. So uncheck the lock and let's say pin number 1. So you can choose any pin, okay, on your choice depending on your need. I have chosen pin number 1. So pin number 0, pin number 1, and pin number 2. Okay. This display, I think, don't worry about the display. This I2C display means on the same pin you can connect. Look at over here, you can connect many. Actually, for I2C display, it uses pin number 4 and 5. Analog pin number 4 and 5. And not only a single I2C device you can connect. You can connect more than 100 I2C device on pin number 4 and 5. Many sensors are I2C compatible nowadays. It is a combination of the single wire, and more than 100 device, up to 100, I think 27 device you can connect. Okay, you can connect display, you can connect sensors, the button. Okay, many devices you can connect on this pin number I2C pin number 4 and pin number 5. So you can expand your system with many sensors and devices with only these 2 pin number 4 and 5. The I2C pin. Okay. So I think now there's no conflict. Let me check the connection of the motor driver. There can pin number 3, 11, 12, pin number 9, pin number 9, 13, 8. So there is no conflict. 0, 1, 3. So there is no conflict in pin. Now we can go for programming. Okay. So let's go to the Visual Designer and we'll do our program over here. I've already created the program, okay, for you beforehand, so we'll follow this one. This is for the setup part. First we'll keep both motors stopped, then we'll create a variable for the rotation direction, okay, integer variable. So let's do it. Let me enlarge it a little bit so that you can view it. So first I just keep for safety, keep both motors stopped. Click the button, this motor 1, and drag and drop. It is drag drop play method. So drag the stop icon, stop function. Okay, for motor 1. For motor 2, similar way, drag and drop the stop function. Okay, now declare a variable of rotation direction over here. So drag the assignment block and double click, new variable, rotation direction. It's integer variable, and initialize the variable with 1. Let's say, for example, okay. So our setup part is complete. You don't need to be expert in programming or program guru, okay, with basic understanding. Just draw your flowchart. Now is the time, is the loop part. Two main part of your Arduino program, one is the setup part and one is the loop part. In the loop part, we will define the program or code that run forever, again and again, okay. So 3 functions will define over here. Start function, no, yes, forward function, reverse function, and stop function, okay. So let's define those functions first, okay. This is the drag and drop. So define the function over here, forward. So give a name, forward. Forward. Okay, so we can define the forward function over here. So let me check the documentation, okay. First we check the button. If we press the button, then we run forward. Okay, let me enlarge it. So how to check the button? Very simple in Arduino, okay, method. There are 3 buttons, button 1, button 2, and button 3. Okay, what is the forward button? Let me check. We will define this button. Okay, this is button 1, 2, and 3. Let's say button 1 is the forward button, for example. So button 1, just drag and drop button 1. Drag and drop button 1. So if button 1 is pressed, there's 2 methods, yes and no. So if button 1 is pressed, what you need to do is run the motor in forward direction. So how to run the motor in forward direction? Run. Motor 1, run. Okay, forward direction, reverse direction you can do. You look over here. If you double click the procedure, you can choose the forward reverse direction. There are several methods about motor 1, run, okay, release, stop, okay. You can choose the run option, forward direction, and you can define the speed. The speed of the motor can be varied in the range in between 0 to 255, okay. Any speed you can choose over here. Let me run at 255 is the highest speed, 0 is the 0 speed. So any speed you can choose, and if you want to make the speed control, then you can use a potentiometer to vary the speed, okay. That means if you vary the potentiometer, depending on your variation in potentiometer, you can choose different value, okay. That's the speed control. I have a video on YouTube how to control the speed. Okay, I'll show you the website. I have YouTube channel that there's a video how to control the speed. Okay, you can check the video. You can check the video. Okay, how to control the speed over there. So this is motor 1. Similar thing in the motor 2. Motor 2, okay. Similar thing in the motor 2. Okay, you run the motor in forward direction at higher speed. Then you display a message. Okay, how to display the message? You define a variable. I think this is unnecessary block, end block, let me delete it. So let me check the word file. You see, you define a message variable and give a value forward. So again, drag the assignment block, drop it over here. Define a new variable, new name of the let's say message, and it is I think string. Okay, type is string. Okay, so value of the message is over here. With the double quote, put the value. Okay, forward. You can write more if you like. So just forward. Okay, message forward. Now how to display the message? You need to call a function called display message, right? This is the function that has been defined. Okay, how to write it? Display message. So let me define the function display message. Okay, choose the flowchart file, right click, new sheet. Okay, if you cannot accommodate all the function in one page, you can create a new sheet. Okay, so right click the flowchart file, new sheet, and give a name to the new sheet. Rename the sheet. Okay, display message, let's say. Display. Okay, so define a function for display over here. Drag and drop the function block and give a name. Okay, give a name of this function, display message. Display message. Okay, so first thing, we'll clear the display. Okay, look at over here. Clear display, then you can set the text color, text size. You can set the cursor at our desired location. So first we'll clear the display, then set the text color. So we'll pick up the function from the SCD. Okay, clear display function first, drag and drop, clear display, then set text size and text color. Okay, lots of function available for the display. Set text size and text color. Set text color. So different color depending on the display you can use. Okay, in this case we have function. Okay, black, white, or inverse color you can choose. Okay, let's pick up the white color. Then set text size. What size? You can choose your size 1, 1.5, 2. Okay, if you take a higher value, larger size will be displayed. Okay, Next thing, you need to set the cursor. At what location you want to display the text? Set cursor. So you can choose the x coordinate and y coordinate. Let's say give it 5 and 10. Okay. Next thing, so after giving the set cursor value, you call the function print, then call the function display. Print message. What you want to print, that you need to specify. Okay. So call the function print. So what you want to print, you need to specify. You want to print message. Click over here and click the message option. So message will be displayed. Whatever is the message, that will be displayed. And we define this message in our main code. Look at over here. In the main code, we have defined our message forward. So when we define the message forward and call the function over here. Okay. Let me finish the function first. After defining the message, you need to call the function display. Drag and drop the display function. Job is done. When this display function is executed, your message will be displayed. So we have defined our display function over here. Okay. Now in the main program, after defining the message content, you can call the function to display this message forward. So how to call the function? This is the function call, procedure call, subroutine call. So drag and drop and define the subroutine. Display message. Okay. So what we have done over here, this is our forward routine. If button is pressed yes, then we will run the motor forward. Both motor run forward, then we will define the message that motor are running forward. Then we'll call the function to display the message. Now, if button is not pressed, what will happen? We will not run the motor forward. Okay. So in that case, this will come here. So this is no function. So we'll drag and drop over here. Nothing will happen. In case button is not pressed, then we will not run the motor forward and will not display the message. Okay, we'll just look and checking the button. Only we'll do the take action when the button is pressed. And the button is not pressed, will not do any job. Okay. Now we'll define the similar way the reverse function. Look at over here. This is the reverse button, button 2. Okay. So drag and drop this block, function block. So similarly we do the thing. Give a name. Reverse. So similar way do it. Check the button, reverse button. And what is the reverse button? Button number 2. So drag button 2. Drag and drop. Okay. If it is yes, then run the motor forward. Motor 1 run reverse direction. Reverse. Backward. Okay. Again motor 2 run backward. You can do different, okay? We can run backward, forward, stop, many things you can do depending on your need, okay? You have all the options over here available over here. So now we want to display the message, right? That we are moving the motor backward direction. What is the message content? Message with double quotation mark, right? Reverse rotation. Okay, reverse. reverse. Okay, and after defining the message content, we need to call the function to display it. So subroutine call and define the subroutine display message. So this particular message will get displayed, that is moving reverse direction. Now in a similar way, we define the function for stop. Again, drag and drop the function block, change the name, stop. And how to stop the motor? Okay, we need to finish the reverse function. If in case you don't press the button, this is this. Okay, don't run the reverse function yet. Okay, if you don't press the button. So for the stop function, what you do? You cut over here. Check the button, stop the motor, display message. Okay, now you need to add some delay, because when you move the motor forward as you press the button from one direction to other direction, it takes some time. So it is always a good idea to give some delay, okay, at the end of each loop. So let me just give a delay at the end of each loop. Okay, how to give the delay? Use this delay function, time delay. Okay, time delay. So for the stop function, again check the button. Button number 3 is the stop button. Okay, if it is pressed, then stop both the motor. So stop the motor, stop the first motor, stop the second motor. Okay, then display the message. So define the message content, stop. And display it. Okay, how to display? Call the subroutine function call display message. Okay, and if it is no, then you don't display the message. You just come over here, and if you just give a delay. Okay, because in between button press, you should give depending on your need. Okay, you can test it in the real hardware, because you can download the program directly to the real hardware by clicking the button. Okay, this is the upload button option. Okay, you can click the program directly to the real hardware by clicking the upload button, and when you test in the real hardware, depending on your need, you can change this delay. Okay, so that it will run smoothly. So what we have done over here, we have defined 3 functions: forward, reverse, and stop. Now in the loop, just keep on calling the function. Call the function forward, call the function reverse, it will run forward. It will just calling the function or checking the button. Okay, reverse, call the function, stop. Okay, so this is your main loop. You just call the function and check the button status and accordingly take necessary action. So we have defined 3 functions: forward, reverse, and stop, and we have defined the function to display the message. Okay, so this is the display message function, and this is our main program. Now is the time to save your work. I suggest try to save your work frequently. Sometimes due to the computer problem, the system may hang, because sometimes it happens. Okay, in some computer, if you have virus in computer or some problem, then sometimes you can lose your work. So it is a good choice to save your work frequently, so that you don't lose your work. Okay, so we have finished our programming part graphically. Once you get habituated to it, you will find that it is very simple. Okay, because you can keep track of very large or big program. You can organize your program in several pages. Okay, and anytime, any portion you can update, modify. It is very convenient rather than conventional programming. Okay, this flowchart based, and the system take care of everything. That means once you click the upload button, it will generate the binary code, and that code will be uploaded to the real hardware, and it will run on the real world. You can simulate over here. Okay, to simulate, press the simulate button, run the simulation. So it is compiling your program and generating the machine code. So you don't need to be programming guru to design a very complex system by this method. With your basic understanding, you can design simple to complex system. Okay, many bigger system you can easily design with this flowchart method. Only you should have your concept and basic knowledge how to use the software. So any one of you, if you want to be a design expert, I suggest that this is a good choice to practice with this flowchart method, and you can quickly become a design expert. So it is simulating your system. Look at over here, 3 buttons has been shown: button 0, button 1, button 2. This is 2 motor, and this is the reset pin. Okay, button 1. Motor is running forward direction. Okay, if you look at the simulation, motor is running forward is at high speed. Button 2. Let me stop. Motor will get a stop. You see? It takes some time. You see, look at over here. When the motor is running, to stop the motor, it takes some time. So I suggest that increase the delay. Okay. A little bit more delay you can give for smooth operation, because motor does not stop instantaneously as you press the button. Okay, it takes some time. Also, this motor driver still has a option called brake option. Okay, you can make use of the brake option. Okay, like in the real car. Okay, you have the brake in the car. Similar way, this motor driver IC has the brake button. So let's move the motor in the backward direction. Press the button. Now motor is moving in backward direction. From backward, certainly you can always use this button, but in real hardware, I think you need to give more delay. Okay, press the forward button. In software, it will run over. It will take some time to stop, then it will run forward direction. Okay, so giving some more delay is a good choice, and by testing your system in the real hardware is the best way to adjust the delay. Let me stop the motor, and you see on the bottom it is displaying the message. Let me check it on the over here. You see. Forward, reverse, stop. Okay, so let me stop the simulation. Now is the time for you to practice it by yourself. Okay, let me upload the Word file that contains this flowchart so that you can do it by yourself.